For today, our lesson was on solving quadratic equations, and we were using two different methods of going about solving these quadratic equations. We were solving by factoring, and we're also solving by taking square roots. So this problem that I'm about to do comes from the section on page 266. Put the page number up here for you. We're on page 266, and this set of problems says to solve by factoring. Okay, so to solve by factoring, I'm going to put this in standard form. It will be a quadratic trinomial. I need to let it equal 0. Okay, so set the equation equal to 0, and I did that by subtracting 3 from both sides. And now I'm going to factor. I'm always looking for a GCF first, but there is no GCF. So then I'm going to try to factor as two linear binomials multiplied together. So just as a review, since my A number in this case is 2, the coefficient of x squared, since that's bigger than 1, I'm just going to review this box method. Doesn't hurt to take a look at it again, because I do want you to know how this works. So we'll put the first and the last terms across from each other, multiply those terms together, and now think of the factors of this term, negative 6x squared, that would add up to negative 1x, and that would have to be negative 3x and positive 2x. Okay, and now just find the 4 GCFs that would be represented in each row and each column. So this top row, the GCF would be x, and the bottom row, the GCF would be 1. For this first column, the GCF is 2x, and this would be negative 3. All right, so this illustrates the factoring. X plus 1 is one of the linear binomials, and 2x minus 3 is the other one. Okay, so that's the factoring, and then the factoring leads us to a solution, because technically you need to think of each of these factors equaling 0 and then solve. All right, so one of my solutions is negative 1. If I let this other factor equal 0 and then solve, I get 3 over 2. So once again, when we're solving a quadratic equation, we're looking for two answers, and the answers are negative 1 and 3/2 in this case. So that is your answer for number 3. Okay, let's take a look at number 4. Solve by factoring. So in this case, I'm looking for a GCF. I don't see one, so I'm going to see if it's possible to factor this as two linear binomials multiplied together. Well, let's see. We know what the signs have to be in both of the groups. Since we have a minus in front of plus, then both of the signs have to be minus. And I'm looking for the factors of 25 that add up to 10, and that should be pretty easy. It's 5 times 5. Now, some of you are going to get to this point, and I expect this. You're going to say, but didn't you say we should get two answers whenever we solve a quadratic equation? And technically we did, although it is the same number, but it's the same number being used twice as a solution. We have a term for this, and we're going to talk more about this in future lessons, but we're going to say that this solution has what is known as multiplicity. And that just means that one number actually serves as a solution in two different times. It could be more than two, but basically more than one time. Here's what this means for the graph. In some of the classes that I had time to kind of develop this idea of what these solutions actually mean as far as the graph is concerned. And I'll just do a quick little illustration of this. For x equals 1.5 and x equals -1, what we've actually found is the places where this parabola would cross the x-axis. And we could just find the middle, just add those two and divide by 2, and this is just a rough sketch, but that helps us find the AOS and the vertex. Okay, so the solution to these quadratic equations, if they're real numbers, they represent x-intercepts. All right, well, what about this, where there's only one number as a solution that's being used, in this case, 2 different times? Well, instead of crossing the x-axis 2 different places, we're only going to cross or touch the x-axis 1 place. So in other words, we only have one x-intercept. That's kind of interesting. So if we're only going to have one x-intercept and it's a parabola, what do you think that means for this number x equals 5? Well, that means that this must be a vertex. The only way that we can touch the x-axis 1 time with a parabola that's opening either upward or downward with these two, with this curve, is that 1 time that's touching the x-axis must represent the vertex. Okay, so just a little preview as to where we're headed in a few lessons. All right, number 11, your directions change, and now you are solving by finding square roots. And just keep in mind that when you're finding square roots or solving by this method, you want to isolate x. In other words, get x by itself. So that's going to mean in this problem we're going to add 15 to both sides. Then we're going to divide by 3 on both sides. And remember, we're on the lookout for 2 solutions because that's the degree of this equation. So I'm going to do the square root of both sides, and anytime I do the square root of both sides of an equation, I need to include plus minus on the right side, the side that contains the number I'm doing the square root of. So my answer here is going to be left in just radical form. You don't need to worry about changing these to decimal form. You can just leave these answers in simplified radical form. So that is your answer for number 11. Okay, let's try number 12. Same instructions. So we're trying to isolate x, so we're going to add 40 to both sides. We're going to divide by 5 on both sides, and then we're going to do the square root of both sides, plus minus. And I do want you to write your answers in simplified radical form. We have not talked this year about how to simplify radicals, but I know you probably were exposed to this in Algebra 1. So I'm going to say it's okay for tomorrow if you leave your answer as plus minus the square root of 8. But what I'm hoping is you'll remember that you could express the square root of 8 as 2 radical factors, one of which has a perfect square root. Okay, so instead of writing the square root of 8, I show it using factors. The square root of 4 times the square root of 2. And the reason why this is helpful is because the square root of 4 has a perfect square root, and then we'll have to leave the square root of 2 in radical form. So maybe you remember that, maybe not. Hopefully what we just did helps just help your memory out a little bit from when you've had this in Algebra 1. But for tomorrow, I'm going to accept this, but you need to be thinking about writing simplified radical form for future problems. Okay, so you might as well go ahead and start reviewing it. All right, 14, you get to pick, actually you need to pick the method that would be the best way to solve the particular problem. So you're solving in this case by either factoring or by taking square roots. So it's kind of like your job to decide which would be the best way. All right, so for 14, I notice First of all, 6 doesn't have a perfect square root, so I'm not going to do the square root method. I'm going to do factoring because I noticed that there's a GCF on this left side of the equation. The GCF would be 2x. So 2x is one of my factors. And the other factor will be obtained by division. If I divide 2x into 6x squared, I get 3x. And if I divide 2x into 4x, I get 2. Okay, so remember, this represents the factoring. And the way we solve these equations that are factored is, okay, so we've got the factoring, and we're going to use the factoring to help us come up with the solutions. Remember, I'm just going to keep this repeating this. We're looking for 2 solutions. Well, let me go back to a previous factoring example, and then we'll make our way back to this problem. Remember this problem? And we came up with the factors. They were linear binomial factors, and basically to find the solutions, we let each of these factors equal 0, and then we solve for x in each case. Okay? Well, keep that in mind when you come to factoring like this. Well, here are my 2 factors. 2x is a factor. 3x plus 2 is a factor. And just like we did on the previous problem, I'm just going to let each of those factors equal 0, and I'm going to solve for x. So on this equation, if you divide by 2 on each side, you get x is 0. For this equation, if you subtract 2, divide by 3, you get x is negative 2/3. So those are my solutions. X equals 0, and x equals negative 2/3. Okay? And that takes us to this word problem. I'm going to do the letter A part, and then I think you should be able to take care of the B part because it's pretty much the same thing. I apologize. I just noticed that this actually should be an exponent. I didn't raise that to the second power. So we have this smoke jumper. Jumping out of a plane. The plane is 1,700 feet above the ground. They give you a function to help you identify the height of the jumper for a given number of seconds after the jump. All right. So remember, y represents the height. All right. So in this function, y is height, and t in this function is time in seconds. Okay, so let's keep that in mind because in these problems they're going to give us a certain number that references height. Okay, the problem says how long is the jumper in free fall, so that means how much time is he in free fall in seconds if the parachute opens this far above the ground. So this would be our height. Well, again, looking at our function, knowing that y represents height, let's just take the 1,000 and replace y in the function. And basically, we're going to be solving for t. Okay, so solving for t means I need to subtract 1,700 from both sides. So that gives me negative 700 equals negative 16 t squared. All right, the next thing to do is to divide both sides by negative 16. All right, so you might want to grab your calculator for this one. It's going to end up being a positive, right? Negative divided by negative. So if you do that in your calculator, you get 43.75. And that's going to equal t squared. Okay, now in this case, since we do want an exact number because we're dealing with a word problem, I do want you to use your calculator and actually come up with the decimal equivalent for this. So we need to find out what the square root of 43.75 is. Now, let's go back to what I said earlier. Earlier, we were solving quadratic equations, and I said to always remember plus minus because you are technically looking for two solutions. Well, in word problems like this, we can throw out the negative of the solutions because there's no such thing as negative time, okay? So just remember, think of the context of the problem. We're looking for an amount of time in seconds, and so it's not necessary to do plus minus here, obviously, because negative time doesn't make any sense. So let's get our calculator, and we'll do the square root of 43.75, and that is 6.61437, and we're just going to round this to the nearest tenth. And so we're going to say t is 6.61. So basically we're going to say that it takes about, and I'll use this little expression for approximately 6.61 seconds. Okay, and you can follow that same procedure when you do letter B on your own. It's basically the same type of problem. They just give you a different number to use for height. Okay, so I hope that helps, and if you have any questions, just contact me, come to Academic Support, and we'll see you tomorrow.